Thank you all for coming out. I hope you've been having a really great Gradle Summit this year. I'm Sterling Greene. I'm a developer for Gradle, and this is my colleague, Stefan Wolf. He's also a developer. So we're going to be talking about moving an existing build that's not using the build cache to taking advantage of the build cache. So a quick overview of our agenda here today. We're going to go over some of the things that Laurent may have talked about yesterday. How many of you guys went to Laurent's talk yesterday about the build cache? A lot of you? Okay, so I'll be nice and quick there. And then we're also going to talk about some build cache concepts. This is to sort of get you ready for some of the demos that Stefan's going to do to show you some of the pitfalls that you can run into in an existing build that seems to work now, but when you enable the build cache, you don't get as much as you think you should get out of it. We're also going to have some time left over at the end for you guys to ask some questions. So if you've already been trying the build cache and you have some questions about some problems you're having or something, you can ask us then. So if you have any questions, just wait to the end. So the build cache. This is a new feature that you may have seen some rumblings of it for the past few releases in the 3x line, but it was first announced in Gradle 3.5. There's a big blog post that you can go read. It's written by me, so I really like that. And we also have made the build cache, the build cache feature we can consider stable for 4.0 for Java projects. So it basically means if you have a Java project and you now run with build cache enabled, then it should work, right? It should be exactly what you expect. So what is the build cache? Fundamentally, what is it, right? It's a way for you to avoid work by stealing other people's work, right? Someone else has already done the work, you can go and steal it. So the build cache uniquely identifies the outputs from your task based on task inputs. So the files, the things like that. So we have a built-in local build cache. So you can have your outputs stored locally on your disk somewhere, and we also share outputs through a remote build cache and a plug to, there's a Gradle Enterprise build cache that you can use. You don't actually have to have a Gradle Enterprise license to use the build cache, but there's a free Docker image that Luke talked about during the keynote yesterday. So yeah, how does this help? So if you imagine like you're working locally and you're switching branches and you're running builds, a lot of times you're building the same commits over and over again, or you're building the same projects over and over again, and nothing's changed. But because Gradle has a single output directory, we have to delete them and recreate them each time. It can also help on CI, where if you're running clean, you're usually running clean builds on CI, but you might be running tests over and over and over again that for projects that have never changed and don't change very often. But because you're running a clean build, the tests have never run before, so we have to run them again. The build cache helps there, where it says, hey, the inputs to these tests, the class path and all that hasn't changed, so why do we need to run it again? We can just go grab the results from the last execution and use that. So in our build, we've been using a version of the build cache since, I guess, November of last year. And so we have some pretty graphs in the blog post about the build cache, how we've been saving things. But we actually save 25% on average. So what that means is that we need 25% less build machine or build time to get a commit through our pipeline. But we also see even higher spikes, like 75%, 80%, that we can save, where we don't, if you change just one thing that doesn't affect many other things, we don't have to run a lot of tests. A lot of that depends on how you're structured, how your project is structured, and how your pipeline works. Okay, so let's talk about some concepts with the build cache. The build cache identifies outputs from each of the tasks by building a build cache key. The build cache key is the implementation of the task, any actions that it has that you've added in like do last, do first, the names of the outputs that it produces, and then the names and the values of the inputs for that task. So that's all the input properties, that's all the input files that you have in your tasks. All of that is used to calculate a cache key. A question that comes up sometimes is my task name an input to a cache key? And right now we say no, it's not. If you have two tasks that compile the exact same code, why not produce? Why is it not producing exactly the same output, even if they have different names? Okay. So the relationship with, in a way, Gradle's had a build cache type of concept for a very, very long time through incremental builds. Basically, if you have the first thing you have to get to really use a build cache is have really good incremental builds. So if your builds, one after another, sometimes are up to date and sometimes are not up to date, that's a sign that there's something going on in your build that's not making it reliable. And you'll just see that same problem magnified with the build cache, where you just won't get very many hits. So what we say is that the first thing you need to do is you need to get incremental builds, and then once you get incremental builds, you can get cacheable builds pretty easily after that. Cacheable tasks just require a little bit more information about how to understand file inputs to your task. But other than that, it's very, very much the same information. Another really important thing that you'll see with cacheable tasks is this idea of repeatable outputs. So the same inputs should produce the same outputs. Those may be byte for byte equivalent, or they may just be semantically equivalent. So what that means is that when we compile a Java file into a class file, a lot of times it's going to produce exactly the same bytes. But if it's producing slightly different ordering or something like that, but the API is the same, that's semantically equivalent, and we can actually treat that as being the same. Another important thing is stable inputs. So these are the idea of when the inputs to your tasks that you want to make cacheable need to not be influenced by, like the time shouldn't be an input to your task. Because what does it mean to, my task, the output of my task depends on it being 12 o'clock, is sort of what it's saying. And that doesn't make any sense. But there's other sources of volatility for inputs to tasks, things like file paths. So if the inputs to your task come from some other place, and that other task embeds absolute paths and things like that, then it makes it really hard to reuse the outputs or get reliable cache hits, because your inputs are path sensitive like that. Another thing you'll see it's maybe the most aggravating is non-deterministic ordering. This is where the implementation usually of your task has like a hash map or something in it, and so depending on the whims of the JVM, it will produce outputs in different orders, or it will see inputs in different orders, and that can really mess up your cache hits. Okay. So one of the tools that Gradle provides for handling kind of all the different things that you can run into with cacheable tasks is this idea of normalization. So there are certain situations where we know there's two things that are different byte-wise are actually the same when you look deeper into them. So if you're using, if you've written custom tasks before, there's this @input files annotation that says this property describes inputs to inputs to my task. And for that, we don't provide any special normalization. We just take the bytes of the files, and we use that to calculate a cache key. But something like this new thing that's in, I think since 3.4, there's a compile class path. Compile class path means take the files in the file collection, extract an ABI from it. So tell me what the public interface to all the class files are, and then that goes into calculating a cache key for my task. So what that means is that if I have a property that is a compile class path property and a jar or class file or something in that property, the internal implementation changes, but the public API is the same, then we don't need to rerun our task. We can calculate the same cache key from what it was before. There's a talk about compile avoidance, I think 440 this afternoon with Cedric. So if you'd like to know more about what kind of compile avoidance we can do, this is even outside of the build cache. This is just normal Gradle features. You can go look at that. And then there's another type of normalization that we, I guess, short-sightedly named class path, which really just means runtime class path. And what that means is that we should treat the files that are in a file collection that are annotated with a class path as if it were a runtime class path for Java. So that means that we need to consider changes to resource files. We need to consider any changes to any task implementations or public API changes or anything like that. And the one thing that we can do is we can look at the timestamps of files inside of a jar or in the directory, and we can just ignore them because timestamps don't matter when looking at a Java compile class path. And we can also look at ordering within a jar file, and we can say, okay, the ordering within a jar file doesn't matter. So if you have a case where you're always recreating a jar file, but it has exactly the same contents, we can actually say, okay, those are the same. We can calculate the same cache key because of that. On top of this, we also provide a mechanism for being able to configure the runtime class path normalization, and we can configure it so that you can say these resources inside this class path don't matter. Right? It would ignore those. And you would really use that for cases where you want to embed like a fingerprint into your jar file that says it was built on Jenkins slave whatever at this time by this user, that sort of thing. That's not something that your application cares about, but that's something you want to use for auditing or something like that. And today, if you were to do that, that would mean, especially if you have like a timestamp or something in there, that would mean that your jar file is like getting recreated all the time. It's a big headache. So these are all things that we have some little demos to show off. I guess for people who have looked into this, has anyone actually tried running their build with the build cache and had anything good or bad happen? I guess anybody using it? Are you guys using it with 3.5 or 4.0, or did you find it earlier? 3.5? Okay. All right. So, you ready to go?
Yeah.
Okay. So I'm going to hand it off to Stefan. If you guys have any questions, please just wait to the end, and we'll, unless there's something you can't actually see, and we'll try to answer them then. All right. I'll let you.
Thank you very much.
Thank you, Daz.
Okay, so I prepared an example for this talk. And let's see. So basically I got a project which has a few sub-projects. It's basically a small application which is somewhat CAD. So we're putting out file input to standard out. And it depends on like a code generation. So we have this build information, which Sterling already talked about. And yeah, there's the application project bundling all that stuff together into one application. So basically what we want to do is we want to make that application cacheable. So this build should be cacheable and make good use of the build cache. So in actually we want to cache our integration tests, and the integration tests are in the test task of the application. So the first thing you should check out when running your build is, like Sterling said, you should check if the build is well behaved with respect to up-to-date checks. So what we're just going to do, we're just gonna run application test twice. It's once, and that should be fully up-to-date, right? Now let's look at it. If you look at the timeline in our build scan, we see that it's not fully up-to-date. So let's just filter by the executed tasks here. Yeah, and actually the test task has been re-executed. And this is one of the tasks we want to cache because the test task is by default cacheable with Gradle 4.0. So we see that the test task was not up to date, and luckily, why is this? Okay.
Yeah, you zoomed in, yeah. You zoomed in, sorry.
Yeah. Luckily, Gradle Enterprise provides us with information about it, so the class path for the test changed, and actually we see that this build info char has changed. Okay, we see the build info char got executed. Okay, we see that this build info properties has changed. Okay, why could that change? Yeah. This was not up to date because the input property current time has changed. Okay, it looks like we have like this. Okay, let's look at the build info project. Yep. I'll get rid of that below. Okay. And we see the build info task, and it's actually creating a file containing the time step and the version in it. And if we just look quickly at this build info.properties, which it generates, we see that actually the version also contains a timestamp. So using this file in a jar file as an input violates the stable task inputs property, which the application test task wants to have, because every time we run the build, we have different task inputs because the class path changes. So what we can do now, we can use this input normalization to actually say, okay, I don't care about the build info properties. I just package it there for some auditing reasons. So let's not consider that file for up-to-date checks. So we just do the following. So normalization, we currently can configure normalization for the runtime class path. And you just can say ignore build info.properties. Okay, and we should be good to go. So let's try the example again. Let's just run application test twice. First time it executes. And the second one, it's up to date. I hope at least. Okay, if you look at the timeline again, we see that the build info char has been rebuilt because we still have the build info properties in the build info char. So we need to rebuild the char, but the test task has actually been up to date. And if you want to look closer at it, you can also do this. Let's see. You can also do the build comparison with actually the previous build. And you just see, okay, so the current time has changed for this build info task, and the char needed to rebuild because it had this input, but all the other tasks had the same inputs. So now we reached already stable task inputs when we rebuild in the same directory. Okay, that's good. So the build seems to respect up-to-dateness, so it's a good incremental build now. So let's continue with caching. So if we want to cache, we expect like the build to be clean. So let's run a clean build and then run test again. And for the fun of it, let's run it again. I got my build cache by default enabled because I'm a very trusty developer and always trust in the build cache, so I always got my build cache enabled globally. And if you see, we pulled actually 4 tasks from the cache. Okay, let's look at the build scan again. So what's pretty good to know here is just look at the performance view of the build scan, so you can see actually which tasks, which cacheable task has been from the cache and which cacheable task have been executed. And then you can just click on here and see, okay, this compiled Java task is cacheable, but has been re-executed even though I did not do any changes actually. So the question again is, why did compile Java run again? And we can again compare just to the previous build. And we got this build info changes we always have, basically. And we look at compile Java, and we see that the source actually changed. But I don't remember changing the source. So what's going on here? So yeah, let's look at the build file. So as you see here, we're using the Antler plugin, and actually we're doing code generation in that build. And so basically, if you want to look at the generated code, that's wrong. So let's look at one of the generated classes, and we see that actually Antler puts in a timestamp as the first line. This is not the best idea if you want to cache this file. So basically, the Antler task has non-repeatable outputs because every time we rerun the task, it actually generates a different file. So, and since the compiled Java task has this as an input, finally we have non-stable task inputs for the compiled Java task. So we need to fix that. So ways to fix it include, we could just, I think the Antler task actually uses a template for the Java files it generates. So we could just adjust the template and remove the class files. I'm doing a little bit of a different trick here. I just say for all Antler tasks, I'll just take all the generated Java classes and remove the first line from it in a do last action. So basically it's the same task for the build cache. It's just got a different action now. Okay, let's try this again, right? And see what's going on here. That looks good, 5 from the cache. So we can look at the performance view again. And we see that now all cacheable tasks are really cache hits. So we can't do any better for this build currently. So awesome, we're done already. We got a cacheable build. So let's break some integration tests. That's what you do when you're developing, right? Breaking some integration tests. So okay, these integration tests, if you look at the build file here, use this integration test samples directory and actually read those samples and compare the contents of the samples. For example, if we just change this file and rerun the build again, it will just fail, right? Oh no, everything's cached, that's great. So yeah, so this is one thing you need to take special care, especially for integration tests, because integration tests often depend on something which you have available for the integration test, which is not captured as a class path, which is always an input to the integration test. So basically we have some missing inputs here, and if you don't declare all your inputs, then caching will give you wrong cache hits, which is probably the worst thing which could happen because you have incorrect builds. And you feel safe, yeah, all my integration tests pass, but actually nothing works. So we need to add this input to the test task, and we do this via the runtime API. So we just add this directory here. And when adding it via the runtime API, it's a good idea to add a name to it. You don't have to, but if you add a name to it, then it doesn't have the name $1, but it just has the name integration test samples. Okay, let's try this again. What will happen now? Hopefully our tests run and they fail. Awesome. And now we can fix the tests again. And they will re-execute and pass. And if I run this again, then they should be cached, right? Awesome, they are from the cache. Okay, now we have a working build, everything's great. So what we have now, we have a build which declares the right inputs, and it works if I run a clean build from the same directory. So the next step is actually, because if you want to share these results between developers or between CI machines, you often won't be in the same directory, but it will be in some other directory. So let's just commit these changes. So yeah, so we made the build cacheable. That's so great. Let's just clone this whole project into a different directory. And now, if we run the same project with pushing to the build cache disabled, we should just have all these caches again, right? So I added a system property to the build cache configuration for this build, so I can just disable pushing. And if I run it, oh no, test got executed. So we can check out again what's going on here. So what happened now, I changed the workspace and the test haven't been pulled from the cache. That basically means if you would run it on a CI machine and then a developer would run it, then you couldn't pull it to the developer machine. Okay, let's see what's going on. So we're gonna do a build comparison again. And we compare it to the last build we had here, which should be used as the cache origin. And if you look at the application test task, we see that actually we have input changes for the input property integration test samples, which we just added. Okay. What could have changed? I mean, we cloned the same project, so the contents of the file will be the same, but actually the path of the file changed. So if you add an input property without specifying anything for path sensitivity, then Gradle will take the absolute path of the file as an input. So what you need to do is you need to explain to Gradle that this property actually doesn't care about absolute paths. And the easiest way to do so is using this path sensitivity. And if you don't know anything better, you just use path sensitivity relative. And if you're going to do this here, so we can run this build again here. So this build will now populate the cache with a changed build script. And now we need to commit this. So we added path sensitivity. And we need to pull the changes. And if we run the build now, everything should be cached again. And let's see. Yeah, and all cacheable tasks are cached again. And we can do the build comparison to the previous build we just ran. So yeah, and we actually see that application test did not have input changes, but as you see here too, the generate grammar source, so this antler task has input changes. It doesn't matter in this case because the task is not cacheable at all, so we will rerun it anyway. And the reason for this is we didn't look at the task yet in the Gradle build itself, so it doesn't have any path sensitivity specified. So this is absolute path changes again. I mean, what you probably also saw at the beginning, this build info char is always changing, but we're actually not compiling the sources of the application again. And this is what compiler avoidance is about. Because compiler avoidance only cares about changes to class files and only to the API of class files. And this build info properties isn't a class file, so it just ignores it by default. Okay, great. Now we have a relocatable build where all the tasks are cached. Okay, great. And this is already the whole example. So we can go over to questions.
Yeah. Okay. Yeah, so let's see if we go back to the slide real quick.
That's the first one.
Yeah. Someone still, yeah, okay. So there are, if you want to see the code for the samples that Stefan just went through, there's a URL here. There's also a URL for the slides, all on the session information for on the Gradle Summit website.
Just an information, if you check out the master branch, then it will be in the fixed state, so in the state we ended up with, and there's a branch called broconverge in the state we started out with.
Okay. So, open up for any questions you guys have. You'd like to know something about the build cache, or problems you might be having, or something we said that was strange. Sir?
So the class file, you said something about just comparing the API. Can you give a little more
Sure. So the question is about how do we calculate the ABI for class files, or what are we doing with the ABI for class files for compilation and things like that. So like I said, there's a talk at 440. We'll talk about that in more detail. But basically what we do is for all the classes that are on a compiled class path, we read the class file and we pull out the pieces that are public or could be public and affect the compilation of the sources that are being compiled, basically. Does that make sense? Okay, sir.
Would it be possible to use input files, for instance, with a native build to still take advantage of the build cache?
Yes. So there's nothing special about compile class path or anything like that. Any of the @input files or @input file or all those things, you can actually put the path sensitivity annotations on it. And if you have your inputs all well defined and you have a good up-to-date build, then basically making it cacheable is adding the cacheable task annotations and adding the path sensitivity information to your task, and then after that it's ready for the cache. There is on the next slide here. There's a link to a Gradle guide that Stefan and Laurent mostly wrote that describes some more of the concepts of the build cache. And I think we'll be working more on providing more documentation examples and maybe another Gradle guide for here's how you actually make a cacheable task from scratch. What we've been focused on so far has been let's make Java really good and then have examples to show people for making their own task cacheable. Okay, let's go back and back first.
In the case where two entries are pushed to the same cache key but have different contents, how is that handled?
So it depends on the cache backend a little bit. The build cache from the Gradle tool side just always says, I have something, here it is. And the way the Gradle Enterprise and some other samples you may have seen that we've had out, they basically just say, I'll overwrite whatever you give me. It could be set up so that you ignore duplicates, or you do something fancier, like you compare and say, does it make sense that these are different or something like that? But right now it's up to the back end to decide what to do if there are duplicates.
So for instance, I could write say a plugin and change that behavior on Enterprise?
So it depends on the implementation of the back end to decide what to do with the overwrites. I guess there's some talk about.
In theory, you could write an own backend which talks to Gradle Enterprise currently, because the HTTP backend is not difficult, and it could just whatever issue ahead and check if the file is there and then ignore it if you really want to. Yeah. I guess Gradle Enterprise will give you more insights into exactly what's happening if you have an override or not at some point in the future.
Yeah. Yes, sir.
So the rail file path looks like a sort of a real bugaboo that you'd want to catch in terms of testing your build scripts, build methodology. Do you have any recommended methodology to automatically catch that as part of maybe using the build testing API or something?
Yes.
So that you guarantee that you catch those errors?
Yeah, so we had some things on our board about actually adding fixtures for test kit. So there'd be like a cacheable task or cacheable plugin or something like that fixture. We have some of that stuff internally. It's not very hard to set up in your test kit test, publish to a local build cache, and make sure that you can consume it when you build in another directory. That's how most of our tests are set up to test for that. I guess we also had talked about, I don't know if we're going to do it now, of changing the default from absolute to relative to cut down on, because I don't think we've really thought of a good example of an absolute path making sense as a default. That's just the way it was for so long.
I mean, we could, for example, think about annotating sort in the source task as relative and have like many tasks which do compilation have this relative path sensitivity by it. But we're not sure we're going to do it, basically. So what our tests are doing, we're also doing like, we have a test which just runs a build, then moves file around in that property, and then runs the build again, and it's supposed to be up to date if I move it around in the right way.
Yeah. So I guess what I would say is that even if you get the path sensitivity wrong, like you forget to set it for absolute pass, it's going to be obvious if you have the Gradle Enterprise stuff. It's going to be more obvious, or at the very least, it just means you get less hits, but you'll still get like the local cache will mostly work for people because
It's not a correctness issue, but it is a performance issue. It would be hard to catch if you weren't looking for it. Is there any way to globally override the default?
There's not right now.
Default?
There's not right now.
Not right now.
No. No. Yes, sir.
One of my coworkers experimented with turning on the build cache at our company, and we saw our build times go down, but some of the folks in our East Coast office saw their build time go up. I think I had heard someone mention being able to replicate the build cache. Is that a committed project, or is that just like an idea that's been floating around?
Yeah. So some of the Gradle Enterprise guys will know better, but that's sort of the idea of the Docker image they have for running a backend. Is the idea of like you can set up these nodes and have them geolocated, and then there's going to be some mechanism for synchronizing between them and picking the best one and stuff like that.
So what we're also going to build into the build tool itself is that you can cache the result from a remote cache, so you don't have to download it every time. You pull the same result again, which is currently the case.
Okay, sir.
Sorry, is it possible to have not the Gradle Enterprise cache backend, but that communicates data to the Gradle Enterprise UI?
What was the question?
So the question was, is there a way of having something that's not a Gradle Enterprise backend communicate to a Gradle Enterprise instance, like just the build scan part? Yeah.
The build scan part is completely independent from the backend. Yeah. So you get the link to the other build, and you get all this information about the inputs, and this is completely independent of the backend.
Okay. Yes, Das.
So just following on from that, does that mean that the free build scans online will give me similar cache debugging information?
Yes, the question is, will the free build scans on Gradle.com give you the same information? I think it's the same version of the application now.
Yeah.
We're very close.
The problem is you don't have any, you only have a single build scan on the public instance. So you get all the up-to-date information, so you can, like this thing I showed at the beginning, you saw which property changed, and you can track it down to a file and say, okay, my build is behaving wrong for up-to-date builds, but you won't be able to compare it to any other build, because you have no build history on the public instance, because there are no accounts yet. That's going to come at some point, but yeah, it's not scheduled yet. So.
Yeah. Okay. Yes, sir.
Okay, so you mentioned that the cache key is computed for the task implementation. So how do you define the task implementation?
So the question is, how is the cache key task implementation determined or found? It's based on the class path of the task. You take the Gradle core API and whatever plugins you have applied and other classes that you define, like in build source and things like that, and those go into the class path of the build, and that class path is then used for calculating the cache key for all the tasks that run there. So I guess it depends on where the task comes from, if it comes from a plugin or if it comes from Gradle core, but it comes from the class loader. Okay. Any other questions? Keep them coming. Yes, no, maybe so. Okay. So the last slide, there's some links to the actual slides for the presentation, links to the buildcash guide that these guys wrote, and also a link to the Gradle Enterprise buildcash page to find out more about that. You can also go bug the guys outside and if you have more questions about the backend.
Or bug us if you have more questions about the build.
You can bug him, yeah. Yeah. Okay, so no more questions? Yes, no? Good? All right, well, thank you for coming out.